right, so here's what you do. I wanted people with partners. So Alex, you know you can do your normal attachment to one of the two groups with you. Now, this first one is very simple. Now, I just want you on 1 through 4, right here, to multiply these with your partner. And please simplify it all the way. Just simple as that. If you would do that, this should be something that we notice. This is back in time to the good old days of algebra 1. And I want you just to go ahead with your partner. I'm going to pause the video so you can finish it, and then we're going to come back together and talk about it. Now, do you guys remember a couple of, see if I can get that to move here. Do you remember what we call binomials that look exactly alike, but only have an addition or subtraction sign different? Remember what we call those? If you do, I'm like so impressed. Similar. They are similar, but they have a special name. And this is a name that you're going to hear me use later when you want some harder type problems when we do later in the year. They're called conjugates. They're called conjugate binomials. Conjugate binomials are two binomials. They have the exact same values in the term, but the only difference between the two of them is a plus. This totally decided to go bigger. Let's not do that. Oh, this did this thing, didn't it? Can you let me edit out of this? Now it likes me. Why? Never mind. I just got to go with this thing. Is it going to let me go to the bottom or to the top? I have no idea. Where is it going to go with this? All right. So we know they're exact opposites. So there's patterns that happen when you're doing this. Now, if you guys foiled, like most of you were doing, like really good students, good job, you should have gotten x squared minus 2x plus 2x minus 4. But what happened to your middle term? All right, so they disappeared, right? They canceled out. They simplified out to be 0. So we get x squared minus 4. Now, there was a special name for this type of binomial. Does anyone remember the special name? What type of number is 4? Perfect square. What type of number is x squared? This is called a difference of squares. So these are called conjugates. And then once we multiply the conjugate binomials together, we end up with a difference of squares. In this case, right? Now, when we did the same thing over here with our quantity x plus 3x minus 3, you got the same thing, x squared minus 3x plus 3x minus 9, and you got what? X squared minus 9. Oh, wait. Is x squared a perfect square? Is 9 a perfect square? Huh. Is it a subtraction problem? That's why we use the word difference, right? If it was addition problem, we'd say what? Sum. So this would be a difference of squares. And then what did you guys get for the next two? I'm not going to write the pattern down. What do we get? X squared minus 25. And then we get what? We got x squared minus 36. All of those, when you multiply conjugate binomials, you come up with difference of squares. Now, what's factoring? When you factor something, do you put stuff together or do you take it apart? Oh, so we go back to its factors. We take it apart. So here's my question. Should you be able to factor x squared minus 4 without a lot of thought? Because remember, when we factor, we're looking for all the factors that have to multiply together to get that algebraic expression. Now notice, do you notice anything kind of special? Are things color-coded? What did I do for the first problem? I multiplied them together. You mean those were the factors that were multiplying together? So what's happening if I want to go backwards and I'm given x squared minus 4? What should be my factors for that? X plus 2 and what? So remember, factoring is you're going backwards. You're like, hey, what things am I multiplying together to get this algebraic expression, and then you use your difference of squares. So x plus 2 and x minus 2. With your partner, how about finishing the other 3 for me real quick? Forever, I know. This is the hardest thing you guys have done all year. All right, friends, what do we get for 6? Yeah, it's x plus 3 and what? X minus 3. Oh, it goes into those conjugate binomials. Our x squared plus 25, what do we get? Awesome. Now, quick question. Look at every one of these we did so far. Could I factor an x plus 5 further? Is there anything else you can do with it? Can you take out greatest common factor? Can you do anything? No, you're pretty much done. You always have to think that when you're doing factoring. All right, what do we get for our last one? Our x squared minus 36. X plus 6 and x minus 6. Okay. Now, after doing that, shouldn't you be able to tell me the rule for factoring difference of squares when I just have a basic pattern? Now, understand A and B, they just represent a term, okay, that is being a perfect square. So what is the rule if you see a perfect square minus a perfect square? What is going to be our rule? Using what we saw in the pattern of it. A plus square root. A plus B times what? Times. That's all it is. Guys, let me show you how simple this is to do, okay? Here's an example of following that pattern. What if I had 4x squared minus 9? Now, a lot of people look at that and they freak because they're like, there's a 4 and there's an x squared. 3. Can I multiply something by itself to get a 4x squared? What value? 2x. So if I ask you to factor that, think about what we have. First thing you can do, could I just go plus or minus here? Yes. All right, let's do easy. How about the 9? What two numbers multiply together 9 that's a perfect square? 3. Oh, so we got 3 and 3. Okay. You should be good at this now. What's the square root of 4x squared? 2 what? How do you know if you're right? Could you multiply it together and see if you got there? But guys, just because there might be variables in there and stuff, can the pattern still hold true as long as you have a perfect square minus a perfect square? Okay, taking it to the next level. You're actually going to learn a new one today. Okay? So, we just got 2 examples here. With your partners, again, I'm going to pause the video for this. Could you please simplify the number 9 and 10? Show all your work. So I want the quantity of x plus 3 times quantity of x squared minus 3x plus 9. I want to know what that is in simplest form. And I want to know y plus 4 times quantity x squared minus 4x plus 16. So when we are working with this one, my friends, let's do the first one. We have x, the quantity of x plus 3 times quantity of x squared minus 3x. Don't we just have to distribute twice, right? Well, I should distribute 2 terms to 3 things is the better way of saying that. So what do you hear? We have x going to x squared, 3x, and to 9. So what do we get here? X cubed minus, double check me guys, 3x squared plus 9x, correct? And then we go, our positive 3 is getting distributed to all 3 of those. We get plus 3x squared minus 9x, and then we go plus 27. Now, what's the cool thing that just happened with all this? Do we have a lot of terms that simplify out to 0? And we get this lovely thing of just x cubed plus 27. Now, using the same type of idea here, I got the quantity x plus 4 times quantity x squared minus 4x plus 6. Doing the same rule, because this is the reason why we are doing this lesson after what we did yesterday. We get x cubed, because I'm distributing the x first, minus 4x squared plus 16x, and then I go and distribute the 4 to all 3 terms, and we get plus 4x squared minus 16x plus I want to make sure your math is right. What is it? 64. Right on. And then do we have the same thing where all these middle lovely terms simplify out and to a zero, so we don't need them, and we get x cubed, plus 64. Now, I want you to look at something. What's so special about my numbers this time? Oh, they're perfect what? Okay. Now, if I asked you to factor, should you be able to go backwards? What would be my backwards moment? What we just had, what? Up above, right? So basically, don't these two go together? So when we're doing that, what should I have? The quantity x plus 3 times, yeah. So the quantity x squared minus 3x plus 9. Okay. What about if I asked you to factor x cubed plus 64? What would we have? So it's minus 4x plus 16. Okay? Now, showing work. I won't believe you unless you show me work. Please do the same thing for 13 and 14. Be careful, watch your signs. So it's good. That's the whole point. Once you learn to fractionize these, then you can always do the raw, and I teach you the raw. And I'm going to give you an example you might like, and these based on help you. I'm just saying, if it helps you learn something. Even if you don't like the team, it could help you remember how to do it. So. All right, see if I can get caught up with you guys. Got my x cubed plus 3x squared minus, plus 9x minus 3x squared minus 9x minus 27. Is that what you guys got? So we got x cubed minus 27. And then I got my x cubed. What are we at? Because I'm distributing. I gotta pay attention to what I'm doing here. Plus 4x squared plus 16x minus 4x squared minus 16x minus 64. And what do we get for this one? X cubed minus 64. Okay. Now, someone brought up, goes like, I couldn't do this if we didn't do what we did before. That's the whole point. But right now, again, what's so special this time? Are they still cubes? They're still cubed, but what was the difference between the top ones? They're negatives. So there has to be something a little nuancy different that's making these different. Well, now if I ask you to factor these, should we be able to go backwards and do that? Yeah, what is going to be our factors for this? If I have x cubed minus 27, what do we have? Aren't we going to have a binomial and aren't we going to have a trinomial? Yeah. All right, what are we going to have? Quantity of x minus 3, and then when we get? X plus 9. Isn't that just what we multiplied together, right? So understand when you're factoring, are we going back to the beginning? All the little pieces that we're multiplying together. I don't know if you call trinomial little, but that's what we're doing. All right, what did you guys get when we do our x cubed minus 64? So when we're doing that, what do we have? You're going to have an x minus 4, and then we're going to have what? X squared. All right, minus, was it plus 4x, excuse me, plus 4x plus what? Shouldn't this one been a plus sign earlier? I was going to say that. Shouldn't that be it? And then plus 16. Sorry, guys. That should have been a plus sign earlier. All right. So, here's the thing. there's a pattern. Everything you notice there is that you had to have what type of numbers this time? Cubes. How many do you have? How many numbers are we working with? How many terms? So we have 2 terms. So we had 2 terms. We had the difference of 2 squares. When we have 2 terms this time, it's just not the difference. We can also have what? The sum. So notice we have sum of cubes, and we also have difference of cubes. This rule we're going to make is going to hold for both. So you are now learning a new factoring method. You have never learned the sum or difference of cubes yet. That's one reason why we wait until you have the cube idea with it. So here's going to be our patterns, and then I'm going to help you figure out some ways to memorize it, all right? Because this is going to be one of those things like in pre-calculus, I review for like 3 minutes and expect you to know for the rest of the year. So this is one of those things you really need to know. So, guys, look at the difference ones, the problems where we had subtraction. Help me figure out the pattern. We know it's going to go into a binomial, into a what? Trinomial. Would you guys agree with me? Okay. So looking at our difference ones, what did we do first? What about our signs? What was about our sign in the binomial? So this would be a minus. Awesome. Okay, now look at the other signs that we have. They're what? They're all plus, plus, correct? All right. Now, let's do what's the pattern for this. Look what happened here. If I had an x cubed, what did I put here? X. So isn't that going to be your A? And then if I have, again, b cubed, which is 27, isn't that just going to be b? All right, now still using those, where do we get this? Look at the next one. What do we have? That's going to be a squared. Then what do we do to get our middle one? We multiply them together. BA or a what? AB. It doesn't really matter which way. It's just when you have them together, they go together. Then, what was our last value? B squared. You have to memorize this pattern. Yes. You might want to wait because we're at almost at a good spot. Now, look back at the sum of 2 cubes. Did we still get a binomial times a trinomial? Okay, what was the difference between these? So the binomial I'm adding this time, but then what changed? Yeah, so the trinomials switched it up a little bit. We have our a squared still, right? But instead of an addition sign here, what do we have? Subtraction. And then we multiplied our 2 values together. And then what was at the end still? Plus b squared. Now, someone goes, how do I know how to do that? You memorize this now, because this rule is true, and I memorized the same rule for both of them, is true for sum and difference of cubes. So some people use the phrase SOAP. Okay? Here's what I mean by this. Some use... There we go. So notice I put them together. It is a phrase used to help you to remember what signs go where. Okay? Now, first thing you need to learn, and that I'm sure you saw the pattern, cubes, sum or difference of cubes go binomial, trinomial. Remember to put in your signs first, and here's how you do this. So the first sign is always going to be the same. So S stands for same. So if you have subtraction, a difference of cubes, guess what goes in my binomial? Difference. Notice I have a sum, which is addition. Guess what I have here? Addition. They stay the same. Are you guys with me on that? Okay. Now, what's the difference between this? Oh, we're going to use the word opposite. And you're going to have opposite sign. So if I have a subtraction here, it's going to end up being addition. If I had addition to start with, guess what this one ends up being? Subtraction. So it's opposite. Then, what's our last sign no matter what? Addition. So the AP, it stands for always positive, or in your head, always what? Addition. So this is always positive. And that goes the same thing, always positive. Now, if you're a baseball player, I actually have the San Diego Padres symbol in the back. It is another acronym that can actually help you memorize how to do sum and difference of cubes. Instead of using SOAP, we use the San Diego Padres. And here's what it stands for. Same exact idea. When we're working with our binomials and trinomials, the San Diego stands for the same. So if it's addition, it goes addition, so that's our same sign goes here. Diego means use a different sign. So do the opposite. So instead of saying opposite, they just say what instead? Different. And then for Padres, this means what? Positive. So this would be your different sign, and then this one would always be addition. So the fact is, it's just another way of memorizing it. Like, if I go to my pre-cal students, I'll go, do you use SOAP or do you use San Diego Padres? It matters literally on what teacher was teaching it. Like Mr. Royce, he loves San Diego Padres. He loves sports. I just do whatever. I just have it memorized at this point. But here's the hard part when you're working with sum and difference of cubes. You have to memorize the rule. You have to know that pattern of AB, A squared, AB, B squared. The signs, that you can do just by memorizing the saying, SOAP or San Diego Padres. Most teachers here at Wayne Academy use SOAP to help you remember the signs. So let's just do one. Actually, let's just wait and do that one. Let's just do a little bit more on here. Let's see if we can work with this quick. All right. Let's see if we can get to a couple things pretty quickly. Guys, should we have other patterns that we should get to fast? Now, here's the thing. Patterns are just that, sometimes patterns, and sometimes memorizing them takes too much time and it's not worth the energy or effort. It's like you're memorizing the pattern and not process. These next couple are patterns, not process. Okay? Process is much better. So could you please use the process and multiply these for me? Let you guys do it. I'm going to silently work up here. Be careful on the last one. If you don't read carefully, could it come back to get you? All right, here's the thing. The last one's cubed. There's not a great pattern. You just have to multiply it out. Here's the stuff. It is a quizzes assignment for the weekend. Are you guys good with that? All right. Go have a phenomenal weekend. And I expect everyone dressed up in fine colors on Monday.